If dark matter became visible tonight, the sky would look completely overcrowded. You'd see huge, ghostly rivers wrapping every galaxy, because dark matter is the extra mass shaping gravity. Right now, we only notice it by the way galaxies spin and by how it bends light. Look at a photo of a spiral galaxy and it feels self-contained. In reality, that bright spiral sits inside a much bigger dark matter halo. Dark matter is matter that barely interacts with light, but it still has gravity. We care because it's the main architecture of galaxies, not the stars. Gravity pulls normal gas inward, and the dark halo tells that gas where to settle. Without the halo, many galaxies would fly apart. Take the Milky Way. Stars orbit at about 220 kilometers per second far out, where visible mass is too low. The simplest fix is an unseen halo, several times the mass of the stars. So the picture is the glitter is small and the invisible bowl is huge. Quick check, if the halo vanished, outer stars would drift away like sparks. Now zoom way out past single galaxies into the space between clusters. That empty space is threaded by a cosmic web made mostly of dark matter. Think of it like scaffolding, where galaxies are the bulbs on the joints. It matters because our current star-based maps miss most of the structure. Gravity amplifies tiny early universe ripples, and dark matter clumps first because it does not feel light pressure. Those clumps stretch into filaments and normal gas falls in after them. If we could see it, we'd watch streams feeding galaxies like slow-motion waterfalls. In simulations, filaments can be tens of millions of light-years long. You'd also spot dark voids where almost nothing ever formed. Seeing it directly would turn guesses into a real atlas. Bottom line, dark matter would redraw the map of everything. Okay, but how do we see something that ignores light? Today we fake it with gravity tricks, especially gravitational lensing. Lensing is when mass bends the path of light, like a glass lens made of spacetime. That matters because it's our cleanest way to weigh the invisible. Astronomers measure tiny stretches in galaxy shapes, then reconstruct the hidden mass like a CT scan. Example in real terms, the bullet cluster shows hot gas separated from most of the mass. The mass peaks line up with the galaxies, not the glowing gas. That is hard to explain without dark matter. Another example, one foreground cluster can magnify a background galaxy by 10 times. One sentence to remember, gravity already gives us a blurry outline of the invisible. So what changes if the outline becomes a full-color picture? First, galaxy behavior stops being a puzzle with missing pieces. Dark matter would appear as halos, wakes, and maybe even ripples from past collisions. We care because problems like why do dwarf galaxies have cores or cusps are basically arguments about dark matter's texture. If dark matter particles collide with each other, halos get puffier and smoother. If they do not, halos stay sharp and clumpy. Example, two small galaxies merging could leave a dark tidal tail, even when the stars look calm. Another example, a fast satellite galaxy could carve a dark wake like a boat. With visibility, you could measure the dark halo's stickiness by its shape. Net result, galaxy evolution would become a lab experiment, not detective work. The really wild part is the early universe. Dark matter starts clumping a few 100,000 years after the Big Bang, while normal matter is still stuck to light. That matters because it sets the schedule for the first stars. When the gas finally cools enough, it falls into pre-made dark wells. Example, the first star-forming halos might be only 1 million solar masses. That is tiny on cosmic scales, but it seeds everything later. You'd also test inflation, because the web's pattern preserves the universe's earliest ripples. Another number, the cosmic microwave background, is about 13.8 billion years old light. Dark matter links that baby picture to today's galaxies. What to remember, dark matter is basically the universe's first draft. Seeing dark matter would also be particle physics in the sky. Dark matter is not one confirmed particle yet, it is a missing ingredient. We care because whatever it is, it sits outside the standard model. If it's a WIMP, you might see slightly fuzzy, thermal-like halos. If it's an axion-like field, you could get interference patterns like cosmic moire. If it's warm, dark matter, small-scale structure gets erased, like smoothing a rough photo. Example, if halos below about 10 million solar masses are absent, that screams warm dark matter. Another clue could be small ripples in halos, caused by wave-like behavior. With direct visibility, you stop debating in words and you start matching textures. Bottom line, the universe becomes a detector bigger than any lab. Now for the strangest what if. If dark matter is an ocean, could anything ever live in it? Dark matter hardly collides, so it is not chemistry-friendly like our world. Still, if it has its own forces, it could form dark atoms and dark planets. That matters because habitability would stop meaning only water and sunlight. Example, some models allow a thin dark disk inside galaxies, like a shadow of our own. If it overlapped the Milky Way's plane, you'd see a dim band crossing the sky. Stars would pass through it and barely notice. Could a civilization use dark matter as a communication medium? Maybe, but only if dark matter can carry signals through its own interactions. One sentence recap, seeing it would expand what stuff is allowed to do. And the practical fallout would be huge. New visibility would demand new instruments, and maybe new energy tech. We care because better maps of dark halos sharpen every cosmic measurement. You might navigate deep space by dark matter landmarks, the way ships use coastlines. Example, a probe could aim for a filament intersection, where gravity gently funnels trajectories. Another example, lensing maps could reveal hidden mass near Earth's path, improving mission planning. Even propulsion ideas change, because you finally know the real mass distribution around you. One sentence recap, making dark matter visible would turn astronomy into exploration. So yeah, if dark matter ever shows its face, the universe won't look emptier. It will look crowded, textured, and alive with structure we've been missing. If you want, tell me which idea you'd chase first, the cosmic web or the particle clue.